Okay, it looks like I'm recording, so I'm going to teach this lesson. Sorry I can't be there in person. Um, I can answer questions when we are in class together, but right now I'm going to go through a very quick intro to geology. You'll have a lot of readings and there should be instructions, so let's get right through this. This is normally when I'd ask you all these questions. I'll ask you them probably in class, so 5 questions. So geology is the study of rocks. Ology, typically at the end of any sort of word, means study of, and geo being the root word for Gaia, the goddess of the earth, is the root word for geo or Gaia, Gaio. So geology is the study of the earth, the physical structure in this, and particularly rocks. Okay, so there we are, and there's some rocks and a puzzle, because why not? Okay, Alfred Wagner. Um, he's this here. He is pictured here, rocking the mustache and the well manicured hair. He's a German scientist who came up with the idea of continental drift back in 1915. Now, a lot of people thought he was crazy because the whole idea of continental drift basically is predicated on our land masses, all the continents, being on basically on top of these this crust that makes up the Earth, and the crust's boundaries are actually under our oceans in some cases, or our mountain ranges. He believed that about 300 million years ago, all the land masses were connected, and then they slowly broke apart. Now, at the time, Wagner was made fun of remorselessly for his theories, but then he was later proved to be correct. So if we were in class, we could watch this YouTube about Alfred Wagner. I will play it for you. It's a song basically summarizing everything I've just said. Okay, so you would have been partnered into 4 groups, but you're not right now. What you should do is you should listen to my instructions, then press pause. So there are 4 readings that are attached to the announcement that this video was also attached to. Press pause and read those 4 readings. I guess press pause after I'm done explaining this. So read the 4 proofs. There are 4 major proofs for the theory of continental drift, which later plays into plate tectonics, which is the proven theory of continental drift. Read the 4 proofs, make notes on them, make sure you know them for future quizzes. This is when you would press pause. Now that you've finished pressing pause, I'm sure that you know all the proofs for continental drift, so we don't have to put them here. So that's great. You've got the proofs. You know how it works. You know why continental drift is what it is. Pangea. Long ago, about 300,000 years, I believe it was. Let's go back. That's the great thing. 300 million. That's a lot longer. You had all the continents gathered together in one giant supercontinent called Pangea. There it is, pictured there, and a very rough drawing. Anyways, and then the evidence for continental drift shows that a lot of these areas split apart. For instance, the mountain ranges that crossed across South America, Africa, and Antarctica, they couldn't have jumped the water, so they must have existed at some point contiguously. Same thing for the animals and plants, the flora and fauna that we find there. They must have traveled across these land masses, but of course they wouldn't have traveled by like water land bridges. This is what people used to think, that there were water land bridges, but there weren't. So anyways, Pangea was a super continent. If you need to remember anything, there you are. And here we show the ultimate breakup of all history when the supercontinent breaks into 7, which is, you know, it's, I don't have any emotions about that, but I'm sure the continent did. Why? Okay, here it is breaking up, and here is the Earth present day. And if we look forward to the future, 100 million years from now, this is what will happen. So Africa right now is kind of moving to the northeast and will crush the Mediterranean Sea. It's gone. You'll see the San Andreas Fault split off over here on the west coast, creating California will be its own little island chain. You can see that the Indian subcontinent has pushed up into Asia further and kind of pushed the Himalayas kind of sideways. So that's kind of, Australia also moved upwards. Look, there's Australia right there, and it moved upwards and collided with Asia. So that's what we will see. And this is the really comforting thing about geology. While we are here and we're experiencing this really frustrating thing of COVID-19, and the chaos of everyday life seems to be almost deafening. Geologically, things just continue no matter what. This will happen whether we're here or not, and it has happened whether we were here or not in the past. So it's really nice to see the cycle, geological cycle at least, continue with or without us. I find something comforting in that. Okay, there's a video, Bill Nye, about C4 spreading. So check it out and answer the questions. There it is, the C4 seafloor spreading there. Watch the video, answer the questions. We'll take them up when we're in class. Okay, so what are we building up to? We've got Wagner coming up with the theory of continental drift. We've got this idea of seafloor floor spreading. We've got the 4 pieces of evidence, actually 5 pieces of evidence that really help explain why the continents moved where they did and help us outline this idea. So plate tectonics theory basically posits that the outer shell of the Earth is made of a crust, and that crust is in motion. And here you can see the edges of the big plates here. There's going to be a whole video about or how this kind of relates to earthquakes for you, I guess, tomorrow or the next day, depending on when you're at home. So roughly 20 plates make up the Earth's outer shell. These plates are floating on mantle, which is magma underneath our cores. Here's a picture of it. So if you could cut the Earth open, you've got the mantle, you've got the inner and outer core, and then this little thin layer is the crust. At some points in the deep ocean, it could be as thin as a few kilometers thick. So the reason the plates move is all a result of convection currents. So essentially, convection currents work like this. You've got the inner core and the outer core. They're really hot, and when you heat a liquid, when you heat anything, it speeds up the atoms. In this case, your mantle is a liquid magma, essentially. And when you heat that liquid magma, it wants to rise. It wants to move away from the heat source. So it moves to a colder area, which is this convection current. So you've got cold things, so cold liquid, cold mantle, becomes heavier because the atoms are moving more slowly, and thus it sinks. So it sinks towards the inner core, and then it gets heated up because the inner core is hot. And so that heating process pushes that warm magma back upwards again. And it creates these little cycles, those little circles called convection currents. And it's those convection currents that cause the different plates around the world to move in various different ways. But that's essentially the process that's happening under the ground that leads to our plates moving into each other or away from each other, depending. The results of these convection currents is, there are a multitude of results. So you can get the 4 here. Basically, you can get a new mountain range. So if 2 plates like collide into each other, you get a mountain range kind of getting pushed up. That's currently what's happening with the Indian subcontinent of, India. It's pushing into Asia. And as a result, it created the largest, the tallest mountain range in the world, the Himalayas, with Everest in there. and it created this giant plateau, the Tibetan Plateau, behind the Himalayas. So that's all a result of two plates colliding into each other. In some cases, if there's action at a plate boundary, you can get a volcano being formed. The seafloor spreading video should have mentioned how, like, when two plates pull apart, you get basically magma coming up out of the ground, and that turns into lava, which dries and then creates a volcano. So that's how you get your volcanic action. So your mid-ocean ridge here, that's your mid-Atlantic ridge that you have cutting down the Atlantic, and that's why you have Iceland. Iceland is essentially a series of volcanoes. So that's another thing you could have. You can have new crust form. That's kind of, again, another, usually in conjunction with volcanic action. So that's another result of moving plates. And then finally, of course, when the plates move, in many cases, there's going to be friction will result, and that friction of those two plates moving is what causes our earthquakes. So let's talk about the three kinds of boundaries, and then you'll have an opportunity to read about some of this stuff. So, divergent. Divergent boundaries. It takes its root word from dividing, so they're moving apart. Here's a picture of Iceland and the mid-Atlantic ridge that cuts through Iceland, and essentially you have North America going one way, the Eurasian plate going the other way. As they separate, they're creating new land, and in some cases volcanoes. That's what those little triangles are. So you've got your mid-Atlantic ridge that actually separates, and you can actually go to Iceland and see the mid-Atlantic ridge. So you can actually stand in between these two areas where the mid-Atlantic ridge is basically being pushed up out of the water, out of the ocean, as new land was created. But you still see this giant ridge between the two plates. It's where the Norse Icelanders used to hold their meetings. They would the structure of Norse and Icelandic culture. They would have a thing called a thing. Actually, it was called a thing, the thing. And what that was a meeting of people who wanted to make decisions for the community. So kind of like our parliament meeting to make decisions for us. Back then, your Viking Icelanders would meet in the mid-Atlantic ridge and have the thing, which was when they decided, what to do about whatever issue. Maybe Vlad, that's not an Icelandic name at all, but maybe Rurik has taken, Ivan's sheep, and they have to figure it out. Well, they would call the thing. Anyways, that was a terrible example, but it was held in the mid-Atlantic ridge. That's a really cool note that I find fascinating. Maybe you fast forwarded. Okay, so Iceland, it's being kind of torn apart. So here's your mid-Atlantic ridge that you can actually swim in the shallow areas near Iceland. The process of it being torn apart is really good because you get this and this. So Iceland's, one of its major attractions is it has a lot of warm springs that you can go in, and supposedly that's relaxing. And the other thing they have is a lot of geothermal electricity because there's a great deal of volcanic activity, and you've got the bottom picture here where people are like, we are slowly cooking. Well, that same process can be used to turn a turbine and thus create power in a power plant. So that's what's happening here. Okay, your next boundary is convergent boundaries, where they converge upon each other. So that's when they collide into each other. For instance, again, Eurasia and India, this is a convergent plate where India is pushing, the Indian subcontinent is pushing towards Asia and thus pushing up a series of the mountains. Now, convergent boundaries can also result in volcanoes and volcanic activity, and can also result in earthquakes. The area of northern India is subject to many earthquakes, and it will be because it's again, these two boundaries are colliding into each other. And so what you have is one plate going under or subducting under the other plate, and as a result, that's going to create friction, which is your earthquake. Now, your third one, your third boundary is a transform boundary. This is when plates go beside each other. This is one of your most common causes of earthquakes. So the North American plate and the Pacific plate in California, your San Andreas Fault, that's what's happening there. Your Cocos plate in the Caribbean with the Atlantic plate, same thing. You've got essentially a lot of sideways movement of these plates. And as a result, you get both mainly earthquakes, some volcanic activity as well, but mostly it's earthquakes. Also, in these areas that have these transform boundaries, you'll find actually along a lot of these different plate boundaries, so along divergent, convergent, and transform boundaries, you'll find archipelagos wherever there's water, and that's a result of the fact that you've got this plate movement, and whenever there's a split in the plate, you get magma coming forth, creating new land. And in the case of, say, Indonesia, the Philippines, all the way up to Japan along the Ring of Fire in the Pacific, you have archipelagos being formed. And now, if you map all of these plate boundaries and you put a map of earthquakes over top, the little yellow dots denote earthquakes, and they make lines. They make lines that conform directly to the plates. So that's why, well, that's, I guess, further evidence of plate tectonics and how it works. You can see that there's many along here. Also, all those archipelagos that I mentioned previously, those are your island chains. Heck, even through the Indian Ocean here, you've got your Seychelles and places like that. Finally, geologists like to call this area, I don't know if they like to, but they do call this the Ring of Fire. Anyways, here it is here going through the Pacific, and it forms a rough ring of fire. Okay, there's a Johnny Cash joke in there somewhere. I'm just not getting it. Okay, but that is roughly the end. This is when we would ask questions. You can email me questions, or we can discuss this further when we are in class. So keep an eye on the Brightspace. I will be updating with what to do for your at-home session if you're cohort B on Tuesday, and cohort A will figure out what we're doing in class. I'll be posting it on Brightspace too. So thank you. Hope you're well, and see you in the class.